Yeah. Shall we start the session for today?
Yes, sir.
Yeah. Last class, in the last thing, we completed about the topic of optics. Now, for today, I'll start a new concept, that is electricity. Understand?
Yes, sir.
Yeah, I'll start the session for you. Yeah, now our topic is about electricity. Better write down. Electricity. So what is this electricity? What the meaning of, electricity, it is a branch of physics, deals with the charges. Okay, write down. What is it, electricity? Electricity is a branch of physics, is a branch of physics, the branch of physics. It deals with it deals with charges and its properties. Charges and its properties. The kind of branch is known as the electricity. Now here it has two sub-branches. Who is having two sub-branches? The electricity has two sub-branches. One is electrostatic. One is what? Electrostatic. Another branch is current electricity. Current electricity. So these are the two branches of the electricity. What are they? Electrostatics and current electricity. See, what is this electrostatics? What is this electrostatics? The electrostatic is also study about charges, but which are at a rest position. We will study the charges which are at rest position. The branch of physics is known as electrostatic. And what about the current electricity? The current electricity, here current electricity. The current electricity is also explaining about charges, but which are in motion. So which are in motion. The study about charges which are in motion is known as the current electricity. The study about charges which are at rest is known as a electrostatics. Study about rest charges is known as electrostatics. Study about movement of the charges is known as a current electricity. As a whole, if you see these total branches, combinedly, all together, if you see that, it is talking about only the charges and its properties. It is talking about what? Charges. It is talking about charges and its properties only. Understand? So, first of all, we should learn about charges. Later, we'll study the other part of the electricity. Understand? Let's start the something and information related to the charges. So let's start about charges. Is it appearing to you? Charges?
Yes, sir.
Yeah, charges. I am talking about charges. Here we have two types of charges. One is positive charge. Another one is what? Can you tell me? What is another one?
Negative charge.
Negative charge. So what is the meaning of the positive charge? What is the meaning of the positive charge? Positive charge means any body having less number of electrons. Any body having less number of electrons is said to be positively charged body. Any object or any body possess possess low number of electrons. Low number of electrons. The object is said to be positively charged body. Positively charged body. Charged object or charged body. So next, same way, next one is what? Negative charge. What does mean by negative charge? Tell me, guess the answer. Any object possess high number of electrons. High number of electrons is said to be negatively charged body. Negatively charged body. So this is meant by positively charged, and this is negative. This is meant by negatively charged body, which means that any object having high number of electrons, then we can say that is a negative charge. Any body having low number of electrons, that's said to be a positive charge simply. Okay, with that we can conclude that what is mean by positive charge and what is mean by negative charge. And next, the charge having some properties. Let's discuss the properties of the charge. Shall I go for the properties of charge?
Yes, sir.
And here, as we have two kind of charges. So now, if you see the two kind of charges and properties of the charges, the charge always charge is conserved. What is the one property? Charge is conserved. What is the meaning of the charge is conserved? Meaning of the charge is conserved is nothing but charge remains constant for a given system. So this is nothing but it is giving the information charge remains constant for the system. Charge remains constant for given system. Either any number of charges are present, the total charge remains constant for the given system. And next, charge is quantized. Next one is what? Charge is quantized. Charge is quantized. What is the charge is quantized? Charge is quantized means the charge always expresses as an integral multiple of subatomic particle charge. So that is charge always express as a integral multiple of subatomic particle charge. Excuse me. As the integral multiple of electron charge. So this statement I can express with a equation also. That is Q is equal to N into E. So that is Q is equal to what? N into E. So this is the expression of the quantization of the charge. So this is a Q means charge. We are representing charge with Q. The Q is always representing integral multiple of electron charge. Here the electron charge is 1.6 into 10 power minus 19 coulomb. But what is this coulomb here? Coulomb is a unit for charge. The SI unit for the charge is what? Coulomb. So the electron charge is 1.6 into 10 power minus 19 coulomb. Okay. So here this is all about the charge. charge properties. And other properties also there, like charges are like charges are repel, unlike charges are attract. Like charges repel, unlike charges are attract. That is one of the property of the what charges. See how the charges repel or attract. If for suppose if I take one positive charge, another is positive charge. In between these two positive charge, repulsion takes place, which means so this will apply, this charge will apply some force on this charge, this charge applies some force on this charge, so that the charges will repel each other. And whereas if you see the unlike charge, this is positive charge, this is negative charge, this positive charge will attract negative charge this direction, this negative charge will attract this direction, so that attraction takes place between the unlike charges. Unlike charges means positive, negative. Like charges means positive, positive or negative, negative. Both may be positive. So anyhow, when between the two charges, what going to be exist between the two charges? Between the two charges, what going to be exist here? The force of attraction or repulsion takes place. But this force of attraction repulsion given by Coulombs with Coulombs inverse square law. So let's talk about Coulomb inverse square law now. Understand? So let's talk about Coulomb's inverse square law. So I am taking this. I'll start now Coulomb's inverse square law. Better write down Coulomb's Coulomb, Coulomb inverse square law. Coulomb is inverse square law. This Coulomb inverse square law will be given by, given by the Coulomb, and it is expressing the force of expression between the two charges. It will give the formula for force between the two charges. Here the force is either maybe attraction force, either maybe it is a repulsion force. For both forces, only one expression, that is given by Coulomb. That law is known as a Coulomb inverse square law. And now I'll explain that how the Coulomb inverse square law and what is the force existing between the two charges. For that, I'll take first of all, I'll take two charges. One is Q1, charge, one more is Q2 charge, are at separated distance R. The Q1, Q2 are the point charges, they are at separated distance R. Now, when the two charges are at separate distance R, between these two charges, some force will exist. The force either may be repulsion or attraction, doesn't matter. So, but anyhow, between these two charges, force is existing. That force is always directly proportional to product of their charges. What is the thing here? The force between the charges is directly proportional to product of their charges, which means that the product of the two charges increases, force between the charges also increases. So that this is the way the relation given by the Coulomb. And one more also relation there, the force also inversely proportional to square of the distance between them. That is the force between the two charges is inversely proportional to square of the distance between them. The force between the two charges is directly proportional to product of their charges. So this is equation 1 and this is equation 2. If I combinedly write these two equations, what going to be happen? F is directly proportional to Q1 Q2 by R square. Q1 Q2 by R square. Now, from here if you remove proportionality, so we should keep a constant, that is K Q1 Q2 by r square. So here this force F is nothing but force between the two charges. K is a proportionality constant and Q1, Q2 are the charges and R is the distance between the charges, separation between the charges. Now here the value of K is 1 by 4 pi epsilon, that is equal to 9 into 10 power 9 Newton meter square per coulomb square. This is the value of K. And now in this formula, the epsilon is representing the permittivity of the free space. It is related to the surrounding medium property. So it is telling that how much of the force allowing through this medium, it is given by the permittivity of the free space. So this is the formula of force between the two charges, and this is only called Coulomb's inverse square law. According to the Coulomb inverse square law, the force between the two charges is directly proportional to product of their charges and inversely proportional to square of the distance between them. Combinedly, you will have F is equal to K Q1 Q2 by R square. Here K value is 1 by 4 pi epsilon, that is equal to 9 into 10 power 9 Newton meter square per coulomb square. This is the Coulomb inverse square law, and it is giving the information to you, force between the two charges. Better write down. Write down. Make it fast.
That is I will.
Are you written?
Yes, sir.
Next, I'll give some questions based on this. Can I give?
Okay, sir.
Yeah, I'll give now some questions to understand, to get better understanding. I'll give you some questions. The questions are, first one is, so there is a example problem I am giving. So there is a Q1, here 1 coulomb charge is present and some other distance 2 coulomb charge is present. This is 1 coulomb charge, this is 2 coulomb charge. The separation between them is 2 meters. The separation between them is 2 meters. Now my question is, what is the force? This is a positive charge, even this is also positive charge. When this is a positive, these two are same charges. These two are same charges, positive and positive. Repulsion or attraction takes place. Which forces takes place between the charges? Repulsion. Repulsion. So which means that this direction. So this is the way repulsion takes place. The repulsion force between the two charges, if I take as a F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, because the K value also I substituted, so that the formula is represented this way. Then what is the answer? Can you tell me? F is equal to, what is the value of 1 by 4 pi epsilon naught? The value of 1 by 4 pi epsilon naught is 9 into 10 power 9. The Q1, Q2 is, Q1 value is 1 coulomb, Q2 value is 2 coulomb. The distance between these two is 2 meters or 2 square. So finally, what is the force here? Force is equal to 9 into 10 power 9 by 2 by how much? This 2 square, so it is 4. 4 ones are 4 twos are. So F is equal to 9 by 2, that is 4.5 into 10 power 9 Newton. So this is your answer for given situation. Understand?
Yes, sir.
Next. So this is a simple formula, simple question I have given to you.
Done, sir.
Next, similar way, one more example problem I will give. Better see. Do it. This one more similar problem. For example, there are Q1 and Q2. There are two charges we have. Between these two charges, separation is R. Between the two charges, the separation is R. When the separation between the charges, what is the force between the two charges? Tell me, what is the force between the two charges? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the force between the two charges. But what has happened here? The distance between the two charges is decreased to half. When the distance between the two charges decreases to half, now what is the new force between the charges? The new force between the two charges, let me take as F dash. Then same formula apply. 1 by 4 pi epsilon naught Q1 Q2 by, what is the distance between the two charges now? It is reduced to half kada, which means that R by 2 whole square. When this is a R by 2 whole square, what is the final answer? What is the final answer? F dash is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square by 4. This 4 you can write here. But this whole thing is nothing but F kada. So F dash is equal to 4 times of F, which means that the force between the two charges is increased to how many times? When we reduce it to half of the distance, the force between the two charges increased to how many times? 4 times. Understand? Note down.
Yes, sir.
Note down.
Okay, sir.
Next, let us take one more problem. Can I take one more problem?
Okay, sir.
Now, similar way, there are two charges Q1 and Q2. How many charges we have? Two charges Q1 and Q2. And the distance between them is R. When the distance between them R and they are Q1, Q2 charges, what is the force between the charges? That is F is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. Q1, Q2 by R square, this is the initial. But here, in that any one of the charge is doubled. One charge, two charges are gets doubled. Okay? When the two charges are gets doubled, what is the new force between the charges? So now let us take that is a F dash. Here F dash is equal to again 1 by 4 pi epsilon naught. Now the charges are doubled, which means that this is become 2q1, another one is 2q2 upon r square. Distance is not changed. Distance is remains same, but the charges become doubled. So 2q1, 2q2. Then F dash is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. But this total thing is representing you as F, so that F dash you can write as 4 times of F. Now in this case also, the charges become doubled without changing the distance. Without changing the distance, if you increase the charge magnitude 2 times, then the force also become 4 times. So this is one of the example. Okay, note down. Completed?
Yes, sir.
Next, here chargification. Next one is what? Chargification. So after this we have one more thing is what? Chargification. How make the charged bodies? So chargification means it is a process of charging the body. How make the bodies charge? We can make the bodies charge by three ways. One is by conduction, actually by friction, by conduction, by induction. These are the three ways we have the chance to make the charged bodies. So let's take first of all by friction. Chargification, first one is what? Chargification by friction. Chargification by friction. So how the charged bodies make by the friction? As you know, if you rub the comb, if you rub the comb to our hair, what going to be happen? The comb gets charged. The comb gets charged because of the rubbing. How the comb gets charged because of the rubbing? Because when you rub the comb with the hair, it loses the comb loses the electrons. The comb loses the electrons or gain the electrons. Because of the gaining or losing the electrons, the body gets charged. Then how do you know the comb have got charged? If you keep this comb near to the any papers, or small piece of papers, the piece of papers gets attracted to this comb. So why the piece of papers get attracted to the comb? Because the piece of papers present also in the piece of papers some negative charges are present. If it is positive charges are exist on the comb, the negative charges is attracted so that they will attract each other. The piece of papers will attract each other because of the chargification of the comb. Even if you rub a rod with silk cloth, if you rub a glass rod with a silk cloth, the glass rod gains the charges. So this is also done with chargification by friction. So this is a way you can rub any uncharged body. You can rub with two uncharged bodies. So what going to be happen? The bodies will get charges because of the transfer of the electrons or charges. So this is how the friction is helping to charge the bodies. And next one more process is what? Charge by conduction. What is that? Next one is charge by conduction. Charge by conduction. Let me take for this I'll take something bodies, two bodies. One body is positive, one body is charged body. Let me take this is a charged body, and one more is uncharged body. This is a charged body, this is uncharged body. Now this charged body keep in contact with the negative uncharged body. What going to be takes place? A transfer of charges takes place by
Yes, sir.
the transfer of charges takes place. When the transfer of charges takes place, then the other body also gets charged. But here, what happened? Here charges will be shared between the two surfaces.
Sir, the conduction will go on and it both have same amount of charge.
Not same amount of the charge, same amount of the potential. The conduction is happened up to the same amount of the potential. The subject actually you don't have. So only you can take that this charged body, this will get charged, even this will get charged because of the conduction. But where we observe this conduction by the, chargification by the conduction, generally in all the situations this process only you are doing. For example, in a plastic chair, the plastic chair will get charged if you sit more time, isn't it? Have you ever experienced this kind of situation, Chaitanya? the plastic chair will get charged. Okay, when you hit the plastic chair by sitting on the chair, if you hit the chair will get charged. Actually, that is a process called friction. But if you touch the charged chair, the charges will share between the you and the chair. So that way, charge happened because of the conduction. And next, one more thing is what? Chargification by induction. Chargification by induction. What is the chargification by induction here? The chargification by induction is nothing but, let me take for example, initially this is a body, this is a body, and this is another body. This is a body, this is another body. Now this body having positive charge. When this object having positive charge, so what going to be happen? This positive charge will attract a negative charge present in this body. Actually, initially this is a neutral body. When you keep a charged body near to the uncharged body, the negative charges present in the uncharged body will move towards one side, and other positive charges will move one more side. Now, if you connect this side to the earth, all the positive charge will go to the earth, which means that here no positive charges takes place. So after after entering all the positive charges, you can disconnect here. We'll disconnect this earthing. When you disconnect the earthing, now only what kind of charges present in this body? Only the negative charges present in the body. So now this is a process of induction by other charged body.